Hi everyone, I'm Kirti R, studying in Sri Venkateshwara College of Engineering, Bhaskara section. Today I'm going to give a briefing explanation of correlation and regression. Correlation and regression. Understanding Karl Pearson's coefficient of correlation. Correlation and regression analysis are statistical tools used to measure the strength and the direction of the relationship between two variables. Karl Pearson's coefficient of correlation is one of the most commonly used methods to calculate the correlation. Contents. Concept of correlation and regression. Karl Pearson's coefficient of correlation. Explanation and formula. Interpretation. Example. Calculating and interpreting Parkinson's coefficient of correlation, exam advantages and limitations, conclusion and final thoughts. The concept of correlation and regression. Correlation. Correlation determines the degree of association between two variables. A correlation coefficient can range from -1 to +1, indicating the strength and the direction of the relationship between variables. Regression is a statistical analysis technique used to determine the relationship between two variables. It involves predicting the value of dependent variable based on the value of the independent variable. Karl Parkinson's coefficient of correlation. Explanation. Karl Parkinson's coefficient of correlation is a statistical method used to measure the strength and the direction of the linear relationship between two variables. The Parkinson's correlation coefficient is the most common way of measuring a linear correlation. It is a number between minus and plus that measures and strengthens the strength and direction of the relationship between two variables. The Parkinson's correlation and coefficient is a descriptive static, meaning that it summarizes the characteristics of a database. Specifically, it describes the strength and the direction of the linear relationship between two quantitative variables. Formula. Perkins's correlation and corregression is the covariance of the two variables divided by the product of their standard deviation. The form of definition involves a product movement, that is, the mean of the product of the mean adjusted random variable. Hence, the modifier product movement is the name. The formula for calculating Perkins's correlation corregression is R equals to summation xy divided by root of summation x square into root of summation y square, where x and y are the variables being analyzed and summation represents the sum of the terms. Interpretation. The value of correlation coefficient ranges from -1 to +1, where -1 represents a perfect negative correlation, 0 represents no correlation, and +1 represents a perfect positive correlation. Now that we have seen a range of positive and negative relationship, let us see how our Parkinson's correlation coefficient of 0.694 fits in. We know that it's a positive relationship. A height increases, weight tends to increase. Regarding the strength of the relationship, the graph shows that it's not a very strong relationship between where the data point tightly hug a line. However, it is not entirely anonymous mob with a very low correlation. It's somewhere in the between. The description matches our moderate correlation coefficient of 0.694. Example, imagine that you're studying the relationship between newborns' weight and length. You have the length and the weight of the 10 babies born last month at the local hospital. After you convert the imperial measurements to metric, you enter the data in the table. So you have the weight and the length of 10 newborn babies. So calculate the sum of x and y. Start by renaming the variables to x and y. It does not matter which variable is called x and which is called y. The formula will give the same answer either way. Next, add up the values of x and y. Calculating the sum of x and y. So let weight equals to x and length equals to y. So now you have to sum the weight, that is x summation x. So you will get the value 33.5. And when you sum, that is add the length, the length, so summation y, you will get the answer as 501.2. Calculate x square and y square and their sums. Now you have to create a new column for the squares of x and y. Take the sum of the new columns, x square and y square. So now you add the x square values, that is summation x square, you get value as 113.05. Now the y square summation, that is adding all the values of y square, you get summation, you get 25,264. Calculate the cross product and its sum. In the final column, multiply together x and y and take the sum of the new column. So calculating the product and its sum. So when you multiply, that is the product of x and y, you get all these values. So after you calculate x and y, that is the product of x and y, now adding that is the summation, you'll get the value as 1684.2. So now you have to calculate the value r. For calculating r, n is already given, that is n equals to 10, summation x equals to 33.5, summation y equals to 501.2, summation x square equals to 113.05, summation of y square equals to 25,264, summation of xy equals to 1684.2. Now the formula of r is n summation xy minus summation of x into summation of y, the whole divided by root of n summation x square minus summation x the whole square into n summation y square minus summation y the whole square. So now substituting all the values, you get the value for r, that is r equals to 0.47. Now calculating and interpreting Perkinson's coefficient of correlation. Calculate Perkinson's coefficient correlation using the formula, ensuring that you have a stable data for the variables you are studying. Interpreting, analyze the value of correlation coefficient to determine the strength and the direction of the relationship. The closer the value to -1 and +1, stronger is the relationship. Visualizing. Plot the data on the scraper plot to visualize the correlation coefficient and see if the trend is linear or non-linear. Advantages and limitations of Perkinson's coefficient and correlation. Limitation. It only measures linear relationship. It assumes that the relationship between variables are constant, which may not always be true. Parkinson's correlation coefficient only describes strength and the direction of the relationship between variables, not the cause and the effect. Advantage: Parkinson's coefficient is widely accepted measure used to many fields such as psychology, finance, and engineering. It is used to describe a linear relationship between two variables. Conclusion and final thoughts. Karl Pearson's coefficient correlation is an essential statistical tool that can help researchers understand the relationship between variables. However, it is not without limitations. Its suitable content, Karl Pearson's coefficient can provide useful information to make informed decisions. As with any statistical fact, it is essential to be aware of its assumptions, limitations, and the content in which it is appropriate to use Parkinson's coefficient correlation. Thank you.